in this question, what they have said, you have to find the value of the entire term. First bracket is 1 plus omega. Second one is 1 plus omega square. Third is 1 plus omega cube, and so on till the last term, that is 1 plus omega raised to 3n. And they have given us some options. Is it 2 raised to 3n or 2 raised to 2n or 2 raised to n or 2 raised to 4n? How should I find this value, guys? Well, we have only two relations which are mostly used. So first one is sum of all the three roots of unity, which are 1 omega omega square. Can you recall what is the sum of 1 omega and omega square? 0, right? Correct. And one more property is used, that is the product of all three roots, that is 1 multiplied by omega square, which will give me omega cube. And what is the value of omega cube, guys? 1. That's right. Bingo. So let's start with the solution part. What we are going to do here is, first, as we have already seen the relation that sum of roots and product of roots. So sum of roots is 1 plus omega square, which is 0, and product of roots omega cube is 1. So how are we going to do this, or how are we going to use this? Let's quickly see. So I'm multiplying here these first three terms. Right? Now, why am I doing this? Because if you see the last term, omega raised to 3n, that means how many terms are totally written? 3n, right? From omega raised to 1 till omega raised to 3n, there are 3n terms. That means I can actually combine three terms like this. And how many actually groups I'll form? N groups, right? First term has 3 terms. Second group also has 3 terms. Third group also has 3 terms, and so on. So I'm combining the first 3 terms. Let's see what do we get. So the first 3 terms is basically 1 plus omega. Well, this by the relation of sum of roots can be written as minus omega square. Right? Similarly, the next term, that is 1 plus omega square, again by the relation of sum of roots, this can be written as minus omega. Clear? Coming to the last term of the first group, 1 plus omega cube. Well, we know omega cube value is 1. So this is going to become 1 plus 1, that is 2. So this entire first group actually came out as 2 multiplied by omega cube, which is equal to 2. Clear? Okay. Now let's see the second group also, because I know that some pattern has to be there, isn't it? So if I write the second group, what am I going to get? My first term will be 1 plus omega raised to 4. Second term will be 1 plus omega raised to 5, and third is 1 plus omega raised to 6. Now what? Well, if omega cube value is 1, guys, quickly tell me what is the value of omega raised to 4? What that is? Omega, that's right. So this value is actually equal to omega. So my first bracket or the first term comes out as 1 plus omega. Similarly, what about this omega raised to 5? Well, again, if my omega cube is 1, I can say that my omega raised to 5 value will be equal to omega square. So this is coming out as 1 plus omega square, and again omega raised to 6 value will be equal to 1, isn't it? So this is again 1 plus 1. Now what? Well, now I have arrived at the relation that my second group is actually equal to the first group, which I have written on the left hand side, and similarly the value of this also will be equal to 2. That means all the groups value will be equal to 2, and how many total groups were there? N, right? So there were n groups. That means if I multiply 2 till n times, the final answer is going to become 2 raised to n. This will be the final value of this entire expression, and if we see the options, I can say that answer will become C. Have you understood? Keep on revising, guys, all the properties of complex cube roots of unity so that you are very well versed with the formula, and then it's quickly and easy to understand what the question is saying and how to proceed. Isn't it? Perfect. Well, moving further, let's see what they have said here. If omega not equal to 1 is cube root of unity, which is satisfying the relation, the first relation is 1 by a plus omega plus 1 by b plus omega plus 1 by c plus omega. is equal to 2 omega square. And we have one more relation, 1 by a plus omega square plus 1 by b plus omega square plus 1 by c plus omega square is equal to 2 omega. Then they have asked what is the value of 1 by a plus 1 plus 1 by b plus 1 plus 1 by c plus 1. Okay, how am I going to solve this out? Well, I have no information about the values of a, b and c, right? So what we are going to do here is, by the two relations which they have given to us, let's try to find some pattern. If I can get some pattern, maybe I can get this value 1 by a plus 1 plus 1 by b plus 1 plus 1 by c plus 1. Okay, very well. Coming to the first term or the first expression which they have given to us. First, what is this 2 omega square? Well, can I write this 2 omega square as 2 by omega? Yes, I can do that. So I have 1 by a plus omega, b plus omega, c plus omega. All are in reciprocals is equal to 2 by omega. Okay. Similarly, about the second term, I have 1 by a plus omega square, then b plus omega square, c plus omega square, all in reciprocals. And guys, this 2 omega again can be written as 2 by omega square. So I have been seeing a pattern over here. I have omega square. Actually, they are following the same kind of pattern, or the expressions are similar. I have to get the value of this expression. So can I say that this will be directly equal to 2 by 1? No, I cannot say it like that. I have to first prove that this value can take only possible value, that is 2 by 1 and no other value. How we are going to do this? Well, if we actually again see my first and second expression, what I can say from here is that these two actually follow this relation, that when I write 1 by a plus x divided by plus 1 by b plus x plus 1 by c plus x is equal to 2 by x. When I put x as omega, I'm going to get the first relation, right? Similarly, when I put x as omega square, I'm going to get the second relation. So what I have to prove, that if suppose I consider this as an equation, I already have two roots for this. One is omega, another is omega square. I have to just prove that one also is a root for this equation. If I can prove that one is the root of this equation, or let's say if I can find the third root and it comes out as 1, that means the value of 1 by a plus 1 plus 1 by b plus 1 plus 1 by c plus 1 can directly be written as 2 by 1, that is 2. Right? Understood what we have to do? Perfect. Let's start with the solution part. So we have seen till now that I have the first expression like this. I have 2 omega over here. The second expression is 2 by omega square. And further what we have deduced, that omega square will be roots of this equation. Now if I take actually LCM on both the sides, I'm going to get a cubic equation. Right? When I take or when I cross multiply x onto this side, and here on the left hand side when I take LCM and multiply the denominator to my right hand side, I'm going to get an expression like this. This will be the expression. I'll have x multiplied by x plus b into x plus c plus x plus a multiplied by x plus c plus x plus b multiplied by x plus a. While on my right hand side, I'll have 2 multiplied by all the 3 terms, x plus a, x plus b and x plus c. Now we'll just try to simplify this out, and let's find which equation do I get whose roots are omega and omega square. Clear? Okay. So we have learned till now that this was the original equation having roots omega and omega square, and we have got the cubic with us. Now we are just going to expand. So let's start with the left hand side. So left hand side, the inside terms, I have x square, again x square, again x square. That means x square is coming 3 times, right? So this is going to be x multiplied by 3x square, right? Then what about terms of x? Well, if I collect my terms of x, it's going to become 2a plus 2b plus 2c. and the constant term is going to become AB plus BC plus CA, right? Okay, what about the right hand side? Well, on the right hand side, I have to multiply x plus a, x plus b, x plus c. So if I multiply the x terms first, I'm going to get x cube. Then I'll have a term of x square. So my x square term will be, when I multiply x and x in two brackets and constant in the third bracket. So when I find the coefficient of x square, it's going to become a plus b plus c, right? Then comes the question, what is the coefficient of x? So my coefficient of x actually will become, when I multiply x and constants in rest of the two brackets, so it's going to be BC plus CA plus AB, and then I have the constant term, that is plus ABC. Clear? So I can say that when I multiply all the terms both on the right hand side and on the left hand side, the final expression actually comes out as this, right? And now we'll just collect the terms. Well, I have 3x cube and 2x cube. So let's bring all the terms to the left hand side. 3x cube minus 2x cube is going to become x cube. Then I have twice of a plus b plus c x square. Here also on the right hand side I have the same term, which is twice of a plus b plus c x square. So that means this is getting cancelled out, right? Then I have AB plus BC plus CA one time on my left hand side multiplied by x, while on right hand side I have twice of AB plus BC plus CA multiplied by x. So when I bring also this to my left hand side, I'm going to get minus of AB plus BC plus CA multiplied by x. Multiplied by x. Clear? And now left only is the constant term, which will be minus twice of ABC. This is equal to 0. This is my cubic equation, and we have already learned that this cubic equation already has two roots, which are omega and omega square. Now what about the third root, guys? Well, to get the third root, let me take the third root as alpha for some time. And now you tell me, guys, what is the sum of roots for this equation? Well, the sum of roots is 0. Why? Because I do not have any coefficient of x square over in this term. That means I can say that alpha plus omega square is 0. Or I can say that alpha value will be minus of omega plus omega square. And guys, what is this value? Minus omega square. Well, that is 1. That's right, because we already know that 1 plus omega square is 0, isn't it? So that means we have just arrived at the relation that third root for this equation will be 1. So if I put my value of x as 1, over in this, I'm going to get 1 by a plus 1 plus 1 by b plus 1 plus 1 by c plus 1 is equal to 2 by 1, that is 2. That means the third root was actually 1, and we have just proved this. And if we look at the options over here, we can say answer is A. So, is this clear, guys? Have you understood? Perfect. Coming to the question, what they have said here is, if alpha is the non-real root of equation x raised to 6 is equal to 1, that means alpha is your imaginary root of this equation. You already know that one root here will be 1, while another root here will be minus 1. So alpha is the imaginary root of this equation. Then they have asked what is the value of this entire expression, alpha raised to 5 plus alpha cube plus alpha plus 1 divided by alpha squared plus 1. They have given us 4 options also. How should I solve this part? Well, to find the value of this expression, first of all, can you tell me what are the roots of x raised to 6 is equal to 1? Well, we have already seen that since alpha is non-real root, I can say the roots for this equation will be 1, then I'll have alpha square, then I'll have alpha cube, then it will be alpha raised to 4, alpha raised to 5. These are the 6 roots of unity. Clear? Now, what are the sum of these roots, guys? Well, we have already seen that since if I write the equation x raised to 6 minus 1 is equal to 0, the coefficient of x raised to 5 is 0 over here. That means the sum of all these roots 1 plus alpha squared till alpha raised to 5 is nothing but 0. That means for the expression which is alpha raised to 5 plus alpha cube plus alpha plus 1 divided by alpha squared plus 1, the numerator part can be written as minus of alpha squared plus alpha raised to 4, isn't it? And this is divided by alpha squared plus 1. Clear? What now? Well, now we can actually take something common from numerator. What that is? Alpha square, that's right. So when I take alpha square common, I'm going to get minus alpha square multiplied by alpha square plus 1 divided by alpha square plus 1. And this part is getting cancelled out. That means I can say that my final answer will come out as minus alpha square. Clear? Just based upon the sum of all the roots of unity. And if we look at the options, we can say answer will be B. Well, moving further, let's see what they have said here. If Z1 and Z2 are two nth roots of unity, then the argument of Z1 by Z2 is a multiple of n pi, 3 pi by n, 2 pi by n, or pi by n. How are we going to solve this out? Well, we know what is the general formula for nth root of unity. How can I write nth root of unity? Well, that can be written as e raised to iota 2k pi by n, isn't it? So I have a z1 and z2. So that means I can take my z1 as, let us say, e raised to iota 2k pi by n, while z2 I am taking as e raised to iota 2m pi by n, where k and m are two different values. Clear? Okay. Now, since I have to find the argument of z1 by z2, I'll first find what is z1 by z2. So my z1 by z2, when I divide these two, it's e raised to iota 2k pi by n divided by e raised to iota 2m pi by n. And finally, it's going to become e raised to iota twice of k minus m pi by n. And what is the argument of this? Well, I can say that e raised to iota theta, when a complex number is written like this, argument is theta, isn't it? So its argument is going to be twice of pi by n multiplied by a value which is k minus m. And guys, don't forget, k minus m will be some integer, right? So if I have the value with me now, I can directly say that this argument of z1 by z2 will definitely be a multiple of 2 pi by n, isn't it? And if we look at the options, we can say answer will be C. Well, moving further, let's see what they have said here. Let z1, Z2, Z3 and Z4 are four distinct complex numbers which are representing vertices of a quadrilateral ABCD in order. That means A is represented by complex number Z1, B is represented by Z2, C by Z3 and D by Z4. Further, they have said if Z1 minus Z3 is equal to Z2 minus Z4, and one more thing they have said, argument of Z4 minus Z1 divided by Z2 minus Z1 is equal to pi by 2. Then what is this quadrilateral? Is it a rectangle, a rhombus, a square, or a trapezium? Okay, well, they have given us two relations, and by that we have to figure out the quadrilateral. Let's see how can we do it. So guys, what we are going to do first is, well, let's try to simplify this relation which they have written. This relation further can be written as Z1 minus Z2 is equal to Z3 minus Z4. Right? Okay. So my Z1 minus Z2 is basically my line which is joining A and B. And Z3 minus Z4 is basically my line joining C and D. Is this much clear? Okay. Now guys, tell me one thing. If I have two complex numbers which are equal, then can I say their argument is equal? Well, yes, we can say that. And one more thing we can say. What's that? Right, we can also say that their modulus will be equal, isn't it? So let's try to solve by using that concept. So from here, I can say that argument of Z1 minus Z2 should be equal to argument of Z3 minus Z4. What does this means, guys? Well, it means that if I join Z1 and Z2, let's say points A and B, so argument of this line is same as argument of line when I join points C and D. And further, I can say that means these two are definitely parallel, isn't it? Okay, so if these two are parallel, can I get an information about the length of AB and CD? How can I get that? How can I get the length of AB and length of CD? Well, yes, you are correct. What we are going to do? We are going to use the relation of modulus. If I have two equal complex numbers, I can definitely say that their modulus will be equal. So that means I can say modulus of Z1 minus Z2 will be equal to what? Modulus of Z3 minus Z4. That means that AB and CD are of equal length as well as they are parallel. So guys, what this is? Well, we can clearly say this has to be a parallelogram, isn't it? So this will be a parallelogram. Now, further what they have said, that argument of Z4 minus Z1 upon Z2 minus Z1 is pi by 2. Guys, let's quickly recall what this represents. Suppose if I say argument of Z by, or let's say Z1 by Z2, or let's say some another complex numbers, I am writing argument of Z by Z0 is equal to pi by 2. What does this represents? Well, it represents that if I have a ray passing through origin and this is my Z0, another ray again passing through origin and Z, angle between these two has to be 90 degree, isn't it? So in this question, actually what they have said that you have a ray joining Z4 and Z1, this will be AD. Similarly, I have one more ray, or let's say a segment which is joining Z2 and Z1, which will be AB. So angle between these two has to be what? Well, this has to be 90 degrees. And if I have the condition that since AB and CD are parallel and equal and angle between AB and AD is 90 degree, guys, can you just tell me what it can be? Well, definitely it cannot be the rhombus, isn't it? Okay, so if this is not the rhombus, it has to be what? Well, we cannot say clearly that it will be a square because for that I have to get the information about AD length also, which I cannot find from here. So I can say only one thing, that since this angle is 90 degree, I can say the figure has to be what? Rectangle. That's right. So this figure will be a rectangle and answer will be option A. Is this much clear, people? Perfect.